Hello again. I thought today I would show you something very simple, my standard sketch. Because I always start with a few standard things that I always do in every sketch. Let's have a look. So let's go to the IoT cloud. I'll click on the Julius test app, which uses that standard code. I'll go to Sketch and I'll open the full editor, which I always use. So here's the bit of code we're talking about. This is my standard template that I always use. What do we see? First, in the beginning, there is always a block that contains some information that's basic, like what is it, when was it written, what does it do, what is its version number, and each time I publish an update, that is also included. That version number goes up, and I document what I do in that update. So then we have the standard versions, which of course we always have, the includes and definitions and the setup and the loop and perhaps the functions. But as you see, I indicate them very clearly with a block of lines around that particular block of whatever it is, because I find that very convenient in seeing what I'm doing, in analyzing my code and looking at it again later. So we start with the includes and definitions, and that first contains the stuff that Arduino puts there. So that's things like the inclusion of the things property and of course all your variables. And here's my my code, and we'll get to that in a minute. Also in the setup, there is some stuff that Arduino puts in there, and you just leave that if it's a web-connected app. And also in the loop, there is actually one line that Arduino puts there, and you leave that as well. You could take those out if it's not a web-connected app. So let's see what I have here. In my standard code, I always include a 1 second counter. I always include an LED for heartbeat. In this case, it's the onboard LED, that's pin 13. And I always include a loop count that outputs to the serial port every time a second passes, how many loops I have done in that second. So I know whether my loop is passed 30,000 times a second or 10,000 or 100,000 or less. If I use delays, I will get less, which I don't want to do, of course. So what else do I see here? I see that I tend to use long variable names, and I tend to keep them lowercase. I know that is not the convention. The convention that Arduino uses is lowercase in the beginning and then a capital letter for every second word. Well, first, I find that confusing. Second, it's more work. But third, I get it wrong half the time, and that leads to compile errors, and compile errors are annoying because compiling, especially on the cloud, takes a while. So I tend to keep my variables to long, legible, but all lowercase names. So I don't use temp, I use temperature if I can. Stuff like that. You will see that every little block is separated by a blank line. That doesn't matter in the code that you send to the device. It's compiled. So it doesn't really matter how long your variable names are at all. It doesn't matter at all how much space you put in there, and especially it doesn't matter also how many comments you put in. And please put in lots and lots of comment. Everything is commented very clearly for two reasons. One is to make this easier to read if someone else ever wants to see your code or adapt it or use it. But of course, secondly, you will be that someone else soon enough. If I look at my code a year later, I can't remember what I did. I have to reverse engineer it, and that's made a lot easier with very clear, copious, lots of code comments. In the setup, other than the Arduino stuff, I define, of course, here what the pin mode is for the onboard LED output, because it's an LED. I set the 1 second counter to millis. That's what it gets compared to. So that means basically setting it to 0. And I set the loop count to 0. And then we get the loop. Very short loop in the basics, right? It has that one line that Arduino puts there. Then it has always my once a second section. I always put in a once per second section. That's the first thing I do because, there are things you might want to do once a second instead of 30,000 times a second, like read variables, for example. It is more efficient that way. And also things like flashing the LED happens once a second. So how does that work? Very simple. If the 1 second counter and the millis are separated by 1,000 milliseconds, that means 1 second, then toggle the onboard LED. And what does that mean? It means read what it is now and write to the onboard LED the inverse of that, the opposite to that. So if it is now on, you write off, and if it's now off, you write on. So it flashes, it toggles once a second. And then the rest of any code that I want to put there. And then in the end, I will print the loops per second count and then set that loop counter back to 0. And at the end of each loop, and here's the end of loop indicator, that loop count is incremented. So that on my serial port, I can see once a second how many loops have been traversed that second. I find that a very good debugging aid. You could take it out later if you want, when the project is completely finished. So that's it. That's my standard code that I always put in. It's well documented. It has spaces between every little bit of code, just to keep it a little bit more clear, because clarity is everything. It really prevents a lot of extra work and a lot of extra debugging that really shouldn't be necessary. So make your own version of this. That will differ from mine, no doubt, but hopefully it'll be as well documented, and maybe these tips are useful. Enjoy!